Welcome to this week's training videos about solving linear equations. Here are the topics that we will cover in this series of videos: working backwards to solve an equation, solving inequalities, and solving when there's an absolute value symbol involved. Let's get started with working backwards. First, a question. What to you is the difference between arithmetic and algebra? Go ahead and pause the video and think about it. Welcome back. Oftentimes, I'll hear students say, well, algebra's got the letters in it. But why does it have the letters? Let's consider an arithmetic equation. Say 3 plus 5 equals 8. Okay. This is where we find the answer. To the right of the equal sign, 8 is the answer. But if we look at an algebra equation, 3 times x plus 5 equals 8. 8 is no longer the answer that we're looking for. We're trying to figure out that what number times by 3 and then increased by 5 will give you the result of 8. And there's certain things that we could do to solve that. But the interesting thing is that we're not looking for 8 anymore. We're looking for this original number. It's an unknown. So we have to have letters to represent an unknown. It's something that we don't know the value of. And of course, we could figure out x equals 1, but we have to work backwards in order to do it. Here's our principle, our first principle of the video. Algebra works backwards. We had to figure out what was there originally. It actually comes from an Arabic word. Looks like that. That's what Google said, but I also fact-checked it with somebody who spoke Arabic. But it comes from a word that means to restore and balance. And so we restore that unknown thing. In order to get there, we use balance. Let's talk about balance. Here's two balance scales. If we look at them just as an equation, it'd be 4 plus 1 equals 5. And x, there's some number of red circles in this envelope. We don't know how many. But increased by 3 is balanced with 7 red circles. So let's say if I take this balance scale, looking at first 4 plus 1 equals 5, and I take away that 1. It is no longer balanced. But if I also take away 1 from the right side, it is still balanced. And the same would be true if I multiplied by the same number, added by the same number, or divided by the same number. As long as I'm doing it to everything on both sides, I am maintaining the balance. So if that's true over here on the right, I can add, subtract, multiply, or divide by whatever I want, as long as it is to both sides. The most efficient thing to add or subtract would be to subtract 3, right? Because that would get the variable low. So if I do that, I have to do it to both sides, and I can figure out that x equals 4. Here's our next principle about these equations. What you do to one side, you do to the other. Right? I like to call it the golden rule. I've also heard students call it the BS rule. Okay, it doesn't stand for Brussels sprouts like you're thinking, but it stands for both sides. Right, the both sides rule. What you do to one side, you do to the other. You'll also have some students who learned this a little bit differently. They learned the change signs method, and what that looks like if I was going to look at, again, x plus 3 equals 7. Instead of writing a minus 3 underneath each side, what they do is they take this operation, whatever it is, and do the opposite, and move it over to the other side. So maybe we'll go, so it looks like this instead. And maybe you learned it that way. That's cool. Both of them are really dealing with balance. So you get the same answer, and you can think about it either way. Alright, so far we know that algebra has to work backwards and that you have to keep the balance. With that in mind, you're ready to learn the 3-step process to solve any linear equation. This is really going to help your students who struggle with knowing what to do when they see an equation. Just follow these 3 steps, and there you go. So here's our process. And we're going to do it with this problem as an example over here. There's a lot going on, so we'll walk through it together. The first thing always is to just simplify what is already there. So we're going to look at one side at a time. First off, there are some parentheses, so we're going to distribute what's in front of them to get rid of the parentheses. simplify it that way. So 2/3 times x is 2/3 x. And 2/3 times 7 is negative 14/3 plus 3x. And then on the other side, there is also something that can be distributed. We're going to distribute the 7/2 inside here. Give that equal sign. 7/2 times x. And 7/2 times 2. That'd be 14/2, but it also simplifies down to 7 and minus 5. So we have distributed, that has simplified what we've had there. Next, we've got some fractions in this problem. Oh no, fractions! A lot of your students who struggle with math especially will be concerned when there's fractions or decimals involved. And you can multiply by a number to get rid of the fractions. It's pretty cool. So if you look at these terms, we have in our denominator 3, 3, and our whole numbers have 1s. And we have a 2 and some more 1s over here. So if you look for the lowest common denominator for those three, it is 6. If you multiply by that number, all your fancy little denominators are just going to go away. Some students will get the common denominator first and then multiply by 6. You can do it either way. So let's multiply by 6 each term. I'm just going to go ahead and write that up here. Let's get a different color. First one, all right, multiply by 6. So here we get 12/3, which simplifies to be 4x. And then we have 14 times 6/3, or you can think about the 3's canceling, however you want to think about it. So 14 times 2 minus 28. And multiply this one by 6. And that gives you 18x. Here we multiply by 6. On the right hand side, 7 times 6 is 42, divided by 2 is 21x. Isn't it nice to multiply the tops by 6? And we get 42 minus 30. So that gets all the denominators gone away, and we're just looking at whole numbers or integers in our problem. Alright, last thing to simplify is to combine like terms. Again, this whole first step is one side at a time. So we're not going to start moving anything until the next step. One side at a time. Let me go ahead and go back to blue. Okay, combine like terms. Ooh, light blue this time. 22x minus 28. And over here, 21x. There's no other variables on this side. 42 minus 30 is 12. Alright, we have finished simplifying. So again, the next step is going to make sure that we get all of the variables on one side. I'm going to add and subtract, got all the variables on one side. So let's move 21x. That's 1x. Don't have to write the 1. And let's move the 28. You can do that in 2 steps if that's more comfortable for you. And you get 40. Now our last step, I just don't need in this problem, is to multiply or divide to get the variable. So let's say if there was like a 5 in front of the x, I'd then divide by 5. If there was a negative, I could multiply by the negative and move it over. Multiply by -1. And so that is our value for x. Now the last step is step 3, but it's always good to check your answers. You want to advise your students to do that. If we plug in 40, it did give me off screen 142 equals 142, which is still balanced and still a true statement. Now this will work, like I said, for any linear equation, 3 steps to solve it. If your students have trouble remembering it, you might want to remind them about this guy, especially if they're fans of Lord of the Rings. That's how I remember it. This is the real hero of the story, Sam Wise Gamgee. Look at that, there's his name. Simplify, add or subtract, multiply or divide, and then it is wise to check your solution. I'm going to have you take that equation to Mordor and throw it in the fire, just like Frodo should have done. So it'll work for any linear equation. Let's look at 2 special cases here, alright? So I'm just going to start solving. I'm going to simplify. 4 times 3x, I get 12x plus 80. Oh, you might have noticed that's the same thing that's already on the right hand side. Okay, but let's just keep going. in case you don't notice that. Let's try to get all of our variables on the same side by adding and subtracting. Oh, again, that is the same thing. Even if we try to subtract 80 equals 80, we're still going to end up with the same thing each time. What that means is no matter what value of x I plug in, if I plug in at the beginning here and here, if I say x equals negative pi, it's going to give me a true statement. If I say 0, it's going to give me a true statement. So all real numbers are a solution for x. You may also hear it called infinite solutions. That means the same thing. Okay, let's look at this other one. Let's start by combining my terms, right? So on the left side I get 11y, 7 minus 6 is plus 1. On the right hand side I get 11y and minus 2. If I try to get all of my variables on one side, they're gone again. And I get 1 equals negative 2, which is definitely not true. This means, when you get something that's never true like this, that no value of the variable is going to work, no matter what I plug in. Even if I plug in 0, it's not going to give me a true statement. So that means there is no solution. A lot of students will get this confused because they feel the situations feel similar, right? In both cases, the variable goes away and you're left with just two numbers on either side. So one way to remember it, on this one I just draw an infinity symbol around the two things that are exactly the same, right? So I remember infinite solutions. For no solution, I will make a not equal sign, right? 1 does not equal negative 2, and that begins my n for no solution. So that helps you to remember it. That is solving equations. Let's go ahead and look at inequalities in the next video.